Hey, 8th grade. Hope you guys are well. I'm excited for today. It's a beginning of a brand new approach to quadratic functions. Well, I shouldn't say that again. Not brand new. We've done some of this stuff already, but hopefully the meaning will take shape for us in the coming days. We're going to take 3.3 and do it over 2 days for right now. Partially because I don't want to rush through it, and I know that we had some mixed perspectives on picking it up, and so we're going to do that here in a bit. I think what we will do is we'll come back to the initial notes that are on 3.3 on page 50 after we talk about what we're doing for part A and part B, kind of a little bit of a different approach, and we'll scale back. We don't have very many questions to do in this one, but we'll talk more about that as we go. All right, here we go. All right, so 3.3, factoring quadratic equations. So if you recall, we actually did some work to figure out that anytime we see a variable to the second power in any setting, it's going to end up being quadratic. And I know this is one of the first times that you have seen this particular setup. So this equation, y equals x squared plus 5x, actually makes this parabola when you plug variables in. And you guys will look at it a little bit more in depthly, but we'll take some time, like tomorrow, more likely to do that. But you can see that if we actually put values of x in, so -7 all the way down to +3, we would end up getting this parabola. Now, when it comes to the solving of those quadratics, which we're not going to do today, but solving, you'll see that we talked about these roots, which are going to be the x-intercepts. And you see here, when we put -5 in, we get 0, so -5, 0, and then 0, 0 is an intercept. What happens is we actually use those two spots to help us with our factoring. And if you recall, we did some factoring earlier on in our book. And so I want to make sure you have a chance to remember some of those details. So, remember seeing our area models, and what we would do is we would pull this apart. We would just split this 5x into something that would come along to help us solve that. So, we're looking at this situation here, this one here. So, to factor x squared plus 5x plus 6, this area model was drawn. So there's a question, or we kind of ask ourselves to be able to know how to split up that 5x. And I want to show it to you now. We're taking a look at that function that they just gave us, x squared plus 5x plus 6. Now this follows the model or the structure of the quadratic function, kind of like how we know what the slope-intercept form is, or the exponential function form is, or inverse variation. This is the structure for a quadratic function. And so we take ax to the second plus bx plus c. And so the value of the coefficient with this front term is what a is. The value of the coefficient with this middle term is going to be what b is. And the final number, which is a constant, is going to be what c equals. So here's the initial question we have for when the value of a is 1. So this is what we need to do. So when a equals 1, here's the question. What factors of c add up to b? That's the main question we ask ourselves. So in this case, I would want to make sure I know, right now a equals 1 because there's nothing there with it. It's a plain old x squared, so that means 1x squared. So then I say, what factors of c? So the factors of c in this case, we know that c equals 6. What numbers are factors of 6? So I know I've got 1 times 6 and 2 times 3. Nothing else really at this point, right? So then, those are factors of 6. Which of these would add up to b? And b equals 5. Well, 1 plus 6 is 7. That's not it. 2 plus 3 equals that. So that's it right there. See, these two are going to add up to that part there. And so what we would do to factor those then is we would split that into our specific little box that they give. And so you see here, they divide the 3x and the 2x for that 6 there, just like that. So if I have this here, They're showing specifically an x squared down here. We like to put ours up here, x squared up here, and then the 6 down here. And then we could do our 3x and then our 2x like that. And then what I would do is I'd begin to factor those out. So what goes out here? Well, x times x is going to give us that. And then obviously we can see, well, x, or this x times what gets 2x, x times 2 here. And then we have our x times what gets us 3. So you can see that, there it is. We have our, so this basically would be factored as x plus 2 times x plus 3. You see how that works? And so this is what they're asking us to do for today. All right, here we go. B, use the method similar to Jakai's to write each expression in factored form. Show why each factored form is correct. Okay, so remember our question. Factors, what factors of C add up to B? So if I look at this, I can see at this point that I know B equals 5 and C equals 4. So factors of C, well, I know I've got 1 times 4 and 2 times 2. So these two guys add up to that B. So if I'm going to do my area model just to figure this part out, and some of you might be able to do this without an area model, but I can take this piece here, I'm going to say, okay, let's go x squared here, and let's go 4 here. Hang on a sec. Actually, we're good. All right, B3. Here we go. So we have x to the second minus 3x and minus 4. All right, so now we have a negative value for C. So I've got my B is equal to -3. C equals -4. So factors of C that add up to B. Now I gotta be careful here because I have a negative number. Remember, the only way to get multiplication to get a negative is I have to have 1 negative, 1 positive. So I need to think about that. So let's try that out here, but I know I'm gonna have a -1 times a +4, and a 1 times a -4, and a -2 times 2, and a 2 times -2. I didn't really have to do that last one. Now, which ones of these would add up to a -3? Well, if I add these guys together, I would get a +3. These guys will be 0, so that leaves me with this one here. Notice how if I add these, I would have a 1 plus -4 would give me a -3. So that's what I'm going to use. So I got my area model. So I'm going to put my x squared here and my -4 here. Be super careful. This has got to be a 1x. It's positive. I have to have my -4x here. So be really careful. All right, so here it is. I have my x and my x. So what times x is going to give me a positive? Okay, so I've got my 1 is coming here. And I've got x times what gets me negative here. And you can see I'm going to have my -4 come in. Now because this is a +1, it's going to end up being x plus 1 and x minus 4 in that case. That's how that one would work. All right, last one, B4, x squared plus 4x plus 4. All right, so our value of B is 4, our value of C is 4. They're both positive, so what numbers we have that factors of C that add up to B? Well, I'm gonna have 1 times 4, and I'm gonna have a 2 times 2. Well, this would be 5, this is the only one, here it is, it's 4. So again, area model. So I'll take my x squared, I'll put my 4 here, I'll split this 4x to being a 2x and a 2x. X comes here, x comes here. X times x is there. So then what times x is 2x? That's going to be 2. And then same thing here. What x times what gets me 2x is going to be 2. And you can see 2 times 2 is 4. So factored form is going to be x plus 2 times x plus 2. And those are done. Hopefully that went well. Wasn't too bad. Our homework tonight is just going to be on these specific types of questions. If you want to push on into doing part C and part D, it's going to get a little bit different because our value of A will change. But I definitely want to show you guys what we have going on for our ACE work for for Wednesday. So for tonight, we only have 24 and then 25A through E only. Be careful on D, it's gonna be a little bit of a tricky one, but 24 all and 25A through D. So they want you to take this and write it to expanded form. And remember, you're gonna put these guys on the outside of the area model, and then you're gonna multiply through to put it back in the expanded form. And then you want these guys to be put into factored form. All right, so I'm gonna look at these here so I can see that I got 1 times 4 is what adds up to 5 in that case. So I'm gonna split that way. So I'm gonna do a 1x here and a 4x here and do that factoring. So what times what would equal x squared? X here and x here. Then I've got, well, what times x is gonna be a 1x? It's gonna be a 1. And then I'm gonna have x times what gets me 4x, so it's going to be a 4. So I've got here factored form x plus 1 and x plus 4. Okay, and that's how that one would work. Now 2 changes the game completely. Really, really different. So what we're going to do here is look at this one because I have a negative 5x. So for B2, I still have x squared. Oops, no, it's minus this time. Minus 5x plus 4. So I gotta see that I've got my B's value is negative 5 and my C value is 4. So I need to get factors of C that add up to B. That's the big thing. But if I get all the positives here, 1 times 4, that's gonna be a positive 5. 2 times 2 is gonna be a positive 4. So I gotta look at some negatives in this case. But if this is going to be positive, it's going to be negative, that's also telling me that both of these guys have to be negative. So if I did a negative 1 times negative 4, that would end up giving me the sum of that part there. So remember, factors of C that add up to B. So let's take that there and go to our area model. And I'll put my let's put x squared here. And my 4 here, this is going to be a negative 1x here and a negative 4x here. So now I've got x and x is coming here now. To be really careful on this one. So what number times x is negative 1x? So it's going to be a negative 1 here. And then x times what's going to be a negative 4? It's going to be a negative 4. So those minuses come in. And this time, sorry, I didn't realize you see that. This time I've got x squared, x minus 1 times x minus 4. Okay, so that's those. So before we release you guys to go and do those on 24, let's review one of those that had the factored form started with and write it into expanded form. So we'll do that from the very, very first example that we had. So let's go back to A and talk about Jakai's method. Here's the factored form. Let's talk about how we would put that back into expanded form. So they gave us x plus 2 times x plus 6. And just as a reminder, because we've done this, but it's been a little while, this time when it's in factored form, these guys are going to go outside the little 4 square court. So I'm going to do my x plus 2 here and x plus 6. And we multiply through to find that out. So x times x is going to be x squared. 2 times x is going to be a 2x. X times 6 is going to be 6x, and then 2 times 6 is going to be 12. And we pull each of those pieces out. So I'd have x squared plus 2x plus 6x plus 12. And because these guys here are similar terms, we would simplify and put them together. So it's going to be x squared plus 2x plus 6x is going to be 8x plus 12. And so that's what you're going to be doing specifically on number 24. You'll take all of these guys right here and put them as pieces on the outside of the 4 square court or the area model. All right, hopefully we'll see some of you guys today in the Google Meetup. All right, see you then, bye.